Very good morning to you students. Now let us discuss the moebius inversion formula. If fn here is called summation of f of d for every positive integer n, then fn is defined as summation of mu of d into f of n by d. So to prove this, let us show that the right hand side is equal to f of n small f. So here we have summation of mu of d, that is RHS, mu of d into f of n by d, where d runs over the divisor of n. So this can be written as summation of mu of d, where d runs over the divisor of n. And what is capital Fn? Capital Fn is called summation mu of d. So here you have f of n by d. So if it is f of n by d, then you have to write here f of n by d is called summation of f of delta, where n by d divides delta, or where delta divides n by d. You just replace this n here by n upon d, and this d you replace it by delta. So we have summation of mu of f of delta. Delta runs over the divisor of n by d. So now we can interchange this summation. We'll put first this one, or delta divides n by d, or we can interchange this n by delta, as in this case you have d divides n. Implies that, by definition of divisibility, implies that n upon d is equal to, say, m, an integer. So this implies that n is equal to md, and then delta divides n by d implies that n by d is equal to delta L for some integer L. So this implies that n is equal to delta L cross multiply L into d, which implies that delta divides n. And also we have here delta divides n by d implies that n by d is equal to delta L, which implies that n by delta is equal to dL, which means that d divides n by delta. So here we can interchange this summation. So we have summation of mu of d into f of n by d, where d runs over divisor of n, as you can see here. So we can write double summation this right hand side, where instead of d divides n, we will write delta divides n, because we can interchange, as you can see from here. So delta divides n, and instead of d here, delta, we can write here d divides n upon delta, because delta divides n by d implies this, and delta divides n upon d implies delta divides n, into mu of d this is f of delta. So this is equal to summation of f of delta divides n, and summation of mu of d divides n by delta. This thing will just write the separation, because mu of d, where d runs over the divisor of n by delta, or delta divides n here, and then f of delta into summation of f of delta divides where delta divides n, and summation of mu of d, where d runs over the divisor of n by delta. And this is nothing but, as if you compare from here, because mu by d here, hence the last sum reduces to f of n. This last sum will reduce to f of n, because as n by delta is equal to 1, because what is mu of d? Summation mu of d, according to definition, d divides n over delta. This is equal to 1 if n by delta is equal to 1. So therefore, as n by delta is equal to 1, as you can see from here, we define Moebius function, mu of d is equal to 1 if d divides over this one, if n over delta is equal to 1. So as this is equal to 1, so therefore this whole sum, it reduces to f of delta, where delta runs over n, which is nothing but f of n. So this completes the proof of the Moebius inversion formula. I hope it is clear to you. Sorry. As the summation of mu of d, where d runs over n by delta is equal to 1 if n by delta is equal to 1. So this whole sum will reduce to summation of f of delta, where delta runs over the divisor of n, which is nothing but f of n. So which is, this is f of n. So this complete the proof. Now the next theorem is, if f of n is equal to summation of mu of d into f of n by d, then for every positive integer n, prove that capital Fn is equal to summation of f of d, where d runs over the divisor of n. So we have summation of f of d, where d runs over the divisor of n, is equal to, what I have to prove is that this is equal to capital Fn. This is equal to double summation d runs over n, delta runs over the divisor of n. You just replace this Fn by f of d, and f of d here you replace it by mu of delta, and then f of d by delta. So this is equal to double summation of mu of d runs over the divisor of delta, gamma, f capital F over gamma, where d runs over divisor of n and gamma divides d. This is by put here gamma is equal to d by delta. So this implies that delta is equal to d by gamma. That is, gamma divides d, and d divides n implies that n is equal to dk. Gamma divides d implies that d is equal to gamma times of L. So this implies that n here is equal to gamma L k. So therefore this summation, now we can write it as summation of f of gamma, where we can interchange here gamma, as you can see here, d divides n. It implies that gamma, as you interchange this summation, so this can be written as gamma interchange the summation. Instead of d, you write it as gamma divides n, and the other summation is d by this gamma n, you replace it by gamma d. Okay, so here we have summation of mu of d by gamma, where d by gamma runs over the divisor of n by gamma. By interchanging this summation, the order of summation, we get this one. So we have here, so this last sum will reduce to f of n as n by gamma will be equal to 1 if and only if gamma is equal to n. If only if gamma is equal to n, because summation of mu of d by gamma, this is equal to 1 if n by gamma is equal to 1. That is, if n is equal to gamma by theorem 1 and it is equal to 0 or otherwise. So therefore this last sum now will reduce, because n by gamma is equal to 1 if and only if gamma is equal to n. So this last sum will reduce, this whole thing will become 1, so it will reduce to f of gamma, and this f of gamma here will be equal to f of n. So therefore this last sum reduces to f of n, which implies that summation of f of d, where d runs over the divisor of n, is equal to f of n.